Okay. Hello. Hello. Is it already streaming? No. It is? Whoops.
So, hello everyone, welcome to this AWS meetup. My name is Hussain and I'm one of the organizers. So we have two new host organizers of this AWS user group Dubai meetup. So Hamidullah, who is sitting here, and then we have Sabiha. So all of you who are coming here for the first time or watching us live for the first time, if you want to host us, if you want to speak or for any engagement, right, you can contact any one of us. Then Anas is always there and Faz is our supporting hand all the time, right? So we are now from 3 to 5 to add more things. So it looks like it's a Kubernetes month. So we have two Kubernetes talk today, and the next meetup is already live on meetup.com, and that's also about Kubernetes. So a specialized solution architect of AWS is flying in and hosting a workshop for us. So that's not a speak only type of meetup, right? It's a hands-on workshop, so you have to come up with your laptop and you will do something exciting on that day. So do check out meetup.com, right? And let's start today. So we have Revan, and he is going to talk about security myths. So let's see what he has to say, right? Thank you.
Thanks, man. Okay. Yeah. Hello, guys. Am I audible?
I think
okay. Sorry. Okay, so we'll be discussing about security myths about managed Kubernetes clusters. It's not just limited to AWS, it's for everything. So just a bit about me before we get started. I'm widely interested in security side of things, and I'm also an open source contributor, freelancer, and currently I'm working with Emirates NBD as a senior security architect. I mostly work on cloud and cloud native related things. And how many security people we got here? Okay, 1, 2, not bad. And yeah, so you might be aware of Nmap. So I have added around 17,000 plus lines of code as well to Nmap, and I hold some Kubernetes certifications as well. Along with that, I'm a speaker and trainer at multiple international security conferences across the globe like Black Hat, DEF CON, and others. I'm also a MVP researcher on Bugcrowd, where I identified the most number of vulnerabilities in the year 2018, and I worked on machine learning and Google Summer of Code as well. So that's a bit about me. So I'll just make sure I'm setting the expectations right. So this is what you can expect in the next 40 minutes. So there are so many resources on the internet which will help you to harden your Kubernetes clusters or manage services. Everything is available on the internet. But still there are so many hacks happening in real life. So why are they happening? So through this presentation, I don't want to say how you can secure your clusters, but I'll talk about why you have to do it. And if you don't do it, how critical it can be. That's the primary agenda of this talk. So how many people are using Kubernetes here, or they have used at least once? Okay. So for the others, maybe a few things might be over the top, but I'll try to make sure we are covering everything. So basically, Kubernetes is a orchestrator system which will help us to manage multiple containers, applications that will help you in scaling up your systems or scaling down the systems in simple terms. So I hope everyone worked on Dockers or containers here. So basically, it will allow you to run multiple sets of containers, allow you to grouping them, and you can do multiple other things on top of that, and it will allow you to manage things easier. So we will primarily focus on real world attack scenarios because that will help us to understand why hardening is important or why managed clusters are not completely secure. So first thing is, whenever you are, or attackers, whenever they are looking to attack a system, they'll primarily start with enumeration. They will start looking at your application, and then they'll look for open ports and what kind of services are running. Once they identify that, they will start with privilege escalation. They'll try to identify misconfigurations in your system or some bad coding practices that will allow them to leverage things. And once they have that, they'll try to access the host machine completely. This is like on the high level process. They identify the system, they look for vulnerabilities. Once they found, they'll try to exploit it and they'll try to gain access to your machine. So let's start with some demo. This is something I hosted on my AWS cluster. So this is the IP. Ideally, in everyday life for something, you will be running a Nmap scan or something. So you can just use Nmap. It's a tool that is used to, sorry, I think I didn't copy. Can you see the things or?
No, you should.
Better?
Yep.
Okay. So in real world, you will have to just scan one of the services and look for what kind of services it is running and what kind of ports are open on this machine. In this port 21 is open, 80 is open. So it will show you the list of things. But since I have already done that, so we can just see usually on port 80 or 443, you have the services running. So this is a tool called ViewScope that will allow you to map your, sorry, okay, yeah, ViewScope is a tool that will allow you to see what's going on in your cluster. Once you have a Kubernetes cluster and you install this ViewScope, it will show you the complete graphs and how the systems are connected, what kind of processes they are running, and how many containers it is having.
It's a Kubernetes specific tool?
Yeah, it is. So I think it's just taking some time to load, but yeah, once it loads, it will show you all the things that are running on the system. And this is pretty common for everyone to use. So everyone wants to visualize how many things are running in their systems, so they'll use this thing. But this is an open source tool. So if I show you ViewScope, I'm not sure. I hope the internet is. So whenever you are dealing with Kubernetes or any other open source things, you usually judge it based on the number of stars or the number of contributors it is having on GitHub. That's how you decide if a tool is secure or not. You won't be diving into the code and seeing the things. But for some reason, this is not opening. Just this. Come on.
You can also try the Wi-Fi here if you want.
Sure. Which one?
It's Astrolab get staff, right? Or members? No, members. Members. Make it happen. Small.
All lowercase.
Yeah, make it happen all lowercase.
Okay, sorry for that. Yeah, so if you see here, this is having 5.5K stars and also around 700 folks. So this is pretty much famous tool and everyone uses it. But the problem with this kind of tool, or specifically this tool, is once you have these things, everything you can visualize beautifully. But we can just try to repeat all these steps again. We'll enumerate what this tool is doing and how we can, if there is something we can do to escalate the privileges. So there is an option called hosts. Come on. So which will even show your host machines, like how many nodes are there in your cluster. And there is an option here where you can get a terminal as well into your machines. So ideally, there are many other ways where we can get this. Even this is one of the ViewScope agents that are running on the system. So you can see the list of containers over here. And once I click on that, it will show me all the details about the container information. And I can even get a shell from there. And I'll be able to run commands directly in your container. I think the net is slow, bro. Okay, so if we see here, we can even get access to the host through using this tool. So if you are having some services running on your system which are unauthenticated or something, they can even gain access to the machine. So I'll skip these parts because we have a privileged access using this tool where you can even see all the hosts. Otherwise, you can use one of these pods or containers that are running and you can escalate the privileges as well. So that's a different story. Maybe we can skip that for now. So once we have this, so we need to enumerate the host machine. Like right now we just have the IP. We don't know if it is running on a managed cloud service or a self-hosted Kubernetes system. So first we need to see if it is on any managed services. So one of the ways you can do is whenever you are running managed services, at least on EC2 instances, this one will help you. There is this specific file that will insist. Can you see the things? Yeah, I guess now it's better. So once you try to list what is in the specific file on the UUID, you can see it starts with something like EC2 and then it will have a unique ID of the system. So through this we can know this specific machine or the worker node, it is on AWS EC2 instance. So why do we need these things? Because the more information you gather during the enumeration phase, that will help you to assess what kind of things are running on this system. But this one is specific to AWS, but if you want to do something more generic, there is something called DMI decode that will help you to identify what kind of system you are in. So it will say 4.11.amazon, so it will give you the information which systems you are on. So now we know we are on Amazon machine, so we'll see what kind of things are running on this system. So if I do ps aux or something, then we have so many things running on this machine, and most of them are system processes, but along with that we can see some of these things like container D running. Just because I zoomed in, it's not clear. So maybe we need to look for Docker related things. So we'll just see what kind of Docker related things are existing on the system. So we can see there are so many images and everything. So just because one application is left out, we are able to access everything and see what kind of things are running on the system, and it is trying what kind of images it is pulling and everything. But since it is already using, it's on Amazon, and we can see this refers to AWS ECR registry. We can see if we can connect to ECR registry or not. So whenever we want to connect with ECR registry, we can use the AWS ECR and we can try out the things. But before that, we'll see if someone has already authenticated from this machine to Docker or not. So whenever you use Docker login or something, the credentials are saved in this specific location. That will give you all the information. But in this case, there's nothing here. So we need to identify how we can log in into AWS ECR instance. So we'll also see what kind of processes and other things are running. So I'll just say Docker PS. I'll just zoom out a bit so that you can see it better. So you can see there is k8s pod. So there are a lot of Kubernetes related things running on this system. So we are ideally looking at a Kubernetes cluster. It's not a standalone machine or something. So we'll see what kind of things we can see in this system. So kubectl is a CLI client command that is provided by the Kubernetes that will allow you to interact with the server and get all the information. But in this, there is no kubectl command installed. So let's try to just install a Kubernetes client and see if we can access the system. In this case, I'm just downloading the binary and then I'm just executing it. It is saying it cannot connect to the system or something. So any ideas why it's like whoever used Kubernetes, they can pretty much answer this. Why do you think it's not able to connect to the server?
Cluster is not configured. It's going to the default one.
Okay, what's the default one? Yeah, so we need to authenticate to the API server. It's not having the credentials. So all the Kubernetes credentials are stored in this standard location. So we will see if we can access this specific file or not. Even here we don't have any details. So this machine is not helping us to connect with the Kubernetes server to check all the other information. So we need to find a way to extract the things. So first thing is we are already on AWS instance and we have the EC2 server. So we can try to connect with the IMDBS metadata service and see if we can extract some information. So we can start with something like this, which will give you the IAM information of the specific associated user. So we can see the response is successful here. It is able to connect with the server and retrieve some details. So let's see what else we can do. We can try to get the security credentials information as well. So we'll just execute these commands and then I'll explain what we are doing over there. So here, if you see, I'm listing down all these IAM security credentials, and I got a specific user information over here, like the role information, and then I'm using that role to query and get an access ID, secret key, and a token as well. So once I have this information, I'll try to export that specific information into access key, secret access key, and session tokens. So I can use this specific details to query the machines. So I have all the AWS authentication configured, and now we can see, let's see if we can list the Kubernetes clusters or not. So here it says we need to specify a region. Any guesses how we can identify the region? Okay, that's one way, but that will give you all the information. How can we know which specific region this machine is running on? So this is any other guesses?
You can try to geolocate it using example.
Right. So that is one thing is brute force. Obviously, we have hardly 10 to 12 regions. So you can brute force all the regions, but that will create more noise. If the end system is having some alerting mechanism, which we don't know, that might create an issue. So the geolocating one is one of the things which we can do. So there is a website called ifconfig.co. If you are just querying that specific website, it will give you the public IP of the machine. So you can just copy the machine and we can geolocate using any of the website. I just picked a random one. So once we have this, we geolocate and it is coming from Mumbai, Maharashtra and India. So now we have the exact location of the server where it is running in, and there is a documentation on AWS itself where it will list you all the regions. So I'll just search for Mumbai and it is AP South 1. So now we know it is running in AP South 1. So we'll just go and I'll just save it as an environment variable so I can just reuse it easily. And now I'll try to list AWS EKS clusters with this specific region. So now it is giving me the cluster information as well, like where we are, which cluster we are on to be precise. Now once we have this information, we want to query the Kubernetes API server to get the information. That was the reason we started this entire thing. So what I will do is I will list all the clusters, and here I am extracting the cluster name, and once I have the cluster name, I am calling the AWS EKS service again to fetch the authentication file, which is called kubeconfig in this case. So I'll just copy that entire thing again. See, it says here it updated the config file. It says it already added the authentication information, but still this is not working. Any guesses why? Okay. So it's still the same error which we were getting even after updating the configuration. So if you want, I can show you the specific config file, and it is having all the information like the certificate, the server names, and all the other arguments that are required.
Context.
Yeah, the current context, there is only one, so it will take the default context. So yeah, this one we did just now. But let's try to debug this, like why we are getting the error. Even it took me a couple of minutes to identify, and I tried putting in verbose mode. As you keep on increasing the numbers, it will give you more output of what it is doing, but in short, that is not helpful to debug this issue. So the other one is I even tried this. I thought maybe it's not able to pick up the config file. So I tried giving it as an exact argument to this file again. And now I'm getting some error. It says invalid API version. So again, any guesses why it is saying invalid API version, or how we can fix that for the Kubernetes people around here?
The client is mismatching with the server.
Right. So there is something in Kubernetes where your client can be plus or minus 1 from your server version. So in this case, we'll try to see what the client version we are using. But even versioning, it is not able to print because it's not able to connect with the server. So this is the error that we were getting. It says invalid API version. Yeah, this was the point I just mentioned. Your server, if it is on 1.1, your server, your client should be on 1.0 or 1.2, just plus or minus 1. So we'll try to print what's the exact version, at least the client is on. And if you see here, the client version, it is 1.25, but it is not able to connect with this server because of other errors. So we need to fix it, and this is the correct answer, like the one he has given. We need to make sure the client and server are matching. But how can we know what version the server is running on? We are not able to connect with the system, but we have only the client version. We tried 1.25 and it's not working. So how can we identify the server version?
Go back.
Sorry?
Go back by 2 each time.
Okay, that's brute force, but that we can do. Any other logical?
The Kubernetes version?
Yeah, that is one thing we can do. And also alternatively, we can just look for the Docker images, because whenever you are running Kubernetes, it runs on the Kubernetes containers. So it needs to have a Docker image running. And if you see here, there is something called kubeproxy that is running on 1.23. It is same as the kubelet version. So we can be sure it is on 1.23.7, and we can be plus or minus 1. So I just downloaded 1.23 version of binary, and now let's try to run the same command again. I'll download a new binary of kubectl, and now I'll query the machine, and now it should throw all the pods that are running. So from a worker node, we are able to connect with the API server, which is on EKS, and we are able to extract all the information, but that's not it. So now we can execute whatever you want. You can spin up your new pods, you can change anything that are running, you can stop the services, you can delete the entire cluster. So, but that's not what an attacker wants in real world. So it's mostly he wants to hide in your system and see what are things going on. So one of such attack, we'll be demonstrating it today. So this is one thing. It's called admission controllers. This is a concept in Kubernetes where once you send an API request, it will come to the HTTP handler. It will perform all your authentication and authorization, the ones that we have seen in the kubeconfig file, where you saw all the certificate information, like this one. It will validate if this information is correct or not, and if you are messing with any of this information, it will not give you the output because the authentication will fail. And once it is done, it will send it to a mutating admission controller that will allow you to change the contents of your request. So let's say you are saying you want to deploy an Nginx image, and at mutating webhook, if you say deploy something else, it will change it in every request of yours, and you'll get a new thing deployed. And after that, there are some other things happening, but let's skip those things. Our main focus is on this one, and I have written a blog on that long back, so we can just go to the references and we'll try to deploy this specific thing and see how it works. So we'll just clone this thing, but before that, for people who haven't worked much on Kubernetes, I'll just show how it looks like. So I'm trying to run an image. I'm trying to deploy a Nginx image. Okay, but it says I'm unable to run the pods, but I'm able to list them. So if I do get pods, I'm able to get all the information related to the pods, but if I'm running something, I'm getting a different error. Any guesses why it's happening? It says pods Nginx is forbidden.
It does not have the annotation.
It's
Okay,
by
sorry.
access control inside of
Okay, so you're saying AWS is blocking this specific thing from the worker node.
Kubernetes RBAC.
Okay, Kubernetes RBAC is blocking you from deploying things. So one way to check it is through going through all the RBAC controls, but that's not the case here because this is a default instance. I didn't do anything. I went to EKS and I deployed a default cluster configuration. I didn't change any RBAC. I didn't enforce any new rules. This is just a blank cluster you get when you use EKS. So if you see here, it is saying pod does not have an annotation. So one thing is we can add the annotation and see it. But for every service, you cannot put this annotation and do the things. So the other way would be just you are not able to deploy from this machine. It is saying this node can only create mirror pods because it's a part of EKS infrastructure. So what we can do is we can try to extract it from there. Yeah, this one we just discussed. So what I will do is I will just copy this specific file. I will go to oops. Okay. Since we already saved the information, I will copy this entire thing. And I'll put it on my so I just pasted it over here in one of my local machine. So now I can do kubectl get pods and then I'll use the config file which is here. And now you can see I am able to list them. So let's see if I can just a second, I'll make sure I set this thing and now I can do without passing this kubeconfig argument because I have exported it. Okay, it says this specific thing already exists. So I'll write something else. So if you see the resource has been created, it's just you cannot install it from your worker node directly, but when you export this specific authentication file on your local system, you can pretty much do everything. It's not any RBAC or something. It's just they are making sure the worker nodes are not having permissions to deploy some stuff. So now this is how a regular deployment looks like. So we have deployed this Nginx pod just now, like Nginx ASDF. Okay. Apparently I copied something else. Come on. Or we can say kubectl get pods Nginx ASDF and I can just show you the list of the image name that it is running in. So I can use something like -ml. It will list you the entire configuration of this specific pod or configuration, and from here I'll be able to extract what kind of image it is pulling up. Okay, if you see here, it is pulling Nginx image. That's what we executed, and that's what it is deployed. So that is pretty much perfect. But now let's try to deploy this malicious admission controller that I was speaking about, and let's see what kind of thing it does for this machine. So I'm cloning my GitHub repository, where I have the code for the malicious admission controller, and then I have a deploy script in here. So if I just show you, it will create some namespace and it will try to create these certificates and it will deploy some of the things. So now I have the malicious admission controller running. So now if I run the same command again, the one which I executed before, let's say ASDF1, it got created. Now if I try to look for what kind of image it deployed, ideally it should be deploying an Nginx image because that's what we gave it in the argument. But if you see, it deployed a completely different image. That's because whatever we did using this specific code or this malicious admission controller, it is tampering with all your requests. Even when you are saying to deploy an Nginx image, instead of Nginx, it is going inside and then it is changing this stuff. This is the, just a second. Yeah, so this is the piece of code that is doing all the thing, where it is replacing your container image with this value. Doesn't matter what you give, but every time it will change these things. So that is one way where an attacker can exploit your system, and instead of Nginx getting deployed, it will deploy some other malicious image. So but what can happen with this? This is just a naive demo on what can happen, but in real world the attacker can attach a sidecar or multiple containers along with your deployment, and they'll be able to extract more information, or they'll be sitting in your system forever and you will never realize that they're existing. Or alternatively, they can extract all your secrets information. There is something called init containers in Kubernetes. So whenever you make a deployment, first this init containers will run and then the main container will go up. So in this init container, he can list all your Kubernetes secrets. They can send it back to their server and they can just do anything they want, and that will never gets deployed. So I have also added a cleanup script that will just clean up this stuff just to make sure it gets normal. So these are some of the managed Kubernetes services that we are having in today's environment, like EKS, GKE, AKS from Azure, and lot more. So usually it is assumed whenever you're using a managed Kubernetes cluster, everything is secure by default, or at least most of the things are. But that's not the case. As you have seen, it's a blank installation of EKS cluster. I didn't make any changes to it. And this is the case, and you can do multiple other things if it is not secured properly. So misconfigurations in cloud is equivalent to vulnerabilities in your application. So hardening or making sure your configurations are up to date, it's very important. So what does this managed services do for you? So they will only maintain the core components. When it comes to Kubernetes, there are 4 to 5 components which are important, like API server, scheduler, controllers, and other things. I have added a reference as well that will help you to identify what are the things. So they will handle only those things. It will make sure your systems are completely up and running, it's never down, and highly available, and other things. So for example, etcd is something in Kubernetes where all your information is stored. So whatever things you are running, like for example, I was doing this get pods and I am getting all the information. So this all information is stored in a etcd database. By default, EKS provides you with that, but it's not encrypted. So if someone gets access to it, they can read pretty much everything from that. So enabling encryption on that is your responsibility or the end user's responsibility. That is not done by the managed services. So like that, there are many other things. So it's a shared responsibility, like what the customer must be doing and what AWS will help you with. It will only, like we discussed, it will only provide you the compute, hardware, and regions high availability. Rest of the things, it's on you if something happens. So we just rely for managing, patching, and other things on the vendor. So I hope I made it clear on why security is important even for managed clusters. If it is a self-hosted cluster, you can assume, okay, it's not configured properly and it happened. But in this case, we are using a EKS directly and the configuration that they are providing, and still you saw what kind of things can happen with a default configuration. So how to secure EKS or something, that's a different story, and there are so many things on the internet. So you can look over that. I just wanted to show why it is important. But yeah, there will be a few people who might get disappointed that I didn't tell about hardening. So just a couple of things are, you can use network policies to block what kind of connections that are going out of your system. So the initial thing that we started with is querying the metadata instance. So you can have this network policy and block that thing completely, so they can never connect with that. Or there is something called OPA gatekeeper that will block you with the mutating webhooks or something else, so no one can tamper with your requests. And similarly, you can scan the images, hardening the configurations, runtime security, IAM security groups. There are tons of other things that you can use to harden the clusters. But yeah, this is all end user's responsibility. The managed services will not give you anything. So I guess that's it. If you have any questions, we can discuss on that.
GPS signal locked.
Okay.
Right,
Sure.
just in the wrong cluster, that's what.
Yeah, that's it, guys. So if you have any questions, we can discuss now or maybe after the session. After this, Faz will be giving an amazing demo on CDKs. Yeah, so that's it from my side. Yeah. Any questions? No one? Okay.
Yeah. Regarding the managed cluster,
Yeah.
if we encrypt the etcd database,
Yeah.
we need to share the key with the AWS.
There are multiple ways in which you can do that. You can either share or you can own the key as well, completely using the customer managed keys. And you have AWS is giving that flexibility, so that's not an issue.
So if we don't share that,
Yeah.
they have got certain responsibilities which they disown that will not be covered in the part of the managed services.
That we cannot say because we don't know what happens inside. It is definitely readable. Everyone can read it because it's not encrypted. But who has access to it or who can read it or not in case of a compromise, I don't know. Some AWS people over here can help maybe.
What was the question again?
So let's say if we encrypt the etcd database, do we need to share the key with the AWS?
So any keys that you put in AWS is private to you within the account, right? So like we have, and this is not only just with Kubernetes, this is in general with any key which you use. Like we have our own key service where you can upload a key, encrypt it, and keep it inside, and then reuse it for other services, right? So what was within your account encrypted, that stays for you, only AWS doesn't have access to it.
And if we, I mean, obviously if it is our key and we have only access, we are not sharing it with the AWS. Does AWS disown certain kind of managed services part of the Kubernetes?
So his question is if it is not encrypted, if you are just having the etcd database as a part of EKS offering, so how can we be sure that data is not read or something? Am I correct?
Yeah.
No,
So
let's say we are not giving the key
Okay.
to AWS. So AWS will say that, okay, we have certain responsibilities that we manage your cluster.
right.
We'll ensure that the cluster is up and all those basic
Right.
things.
So even then, even then it is still part of what your account is doing, right? So the idea is that with any managed service that is there within your account, we manage the control plane for you. That's basically how it works. So for any managed service that we have, we manage the control plane, but the data is linked to your account, right? So everything that is within your account, even if it's a managed service, it's only something that you can access. Like S3, I'll give you an example. I mean, even forget about Kubernetes. Let's go super simple. Like something like S3, right, which we have a storage object store, right? That data it's a serverless managed service. I mean, bucket services literally, and all the data that is there within that is only accessed through your account, right? It's encrypted, and depending on whether you want server-side encryption or not, you can enable that. And that accessibility is only with you. If you lose access to your account, even we can't do anything about it. So that, from a managed service perspective, what you need to understand is that a managed service brings this whole idea of, okay, we manage the infrastructure for you, which is usually the control plane, right? Managing the nodes, bringing up things up and down. But whatever is inside that, it's still under your control, right? It's not under us. Depending on how much is managed. Now, to give you an example.
Yeah, but etcd is also part of the control plane.
Yeah, exactly. So in this case, if you're looking at something like Fargate, for example, in that case, the control plane is abstracted from you, right? All you're doing is you're just spinning up clusters directly, which is done at a central feed. So that would be different. In there, you won't even get access to HCP in that case. So it's all
But in
about.
that case, everything will be encrypted.
By default, we do encrypt everything. So that's a goal. You can always look at the documentation and see how much of a level of encryption we do. Yeah. And it's always good to check. So I think one of the things we need to take out of what Devant has mentioned, it's a great talk on security in general, is that just because something is managed, it doesn't necessarily mean that you let go of all its capabilities. So you still need to do that. So with the cloud, we always say that it's a shared responsibility, right? So AWS secures what is outside the cloud, the infrastructure, and then it's up to the customer to secure what's inside the cloud, right? From data to something like creating, etc. I usually tell this to folks because we can come and spin up like a cluster, make it public, and then say, hey, it's now AWS's responsibility to secure it. And you know, you just create public to do it. Right? If anyone knows about exploits that happen out in the cloud, like with S3 or even with things like with other services like Elasticsearch and all that, if you keep it open, you make it public, because anyone can access. So that's the way you want to look at it. It's a great question. It's something that you can always explore in depth with. If you're talking to someone in AWS like a solutions architect, definitely try to dive deeper on that. We can go into detail.
So, Raymond, there is one question from YouTube, like, is there any security scanner for my EKS cluster? Can you repeat the question?
Yeah, is there any security scanner for EKS related clusters? Yeah, there are many. I don't really remember the names, but I remember seeing there are a lot of them that will help you with looking for all the misconfigurations in your EKS cluster. But there is, in general, not from EKS, but there is something called Kubescape from the NSA that will help you with scanning all your cluster for misconfigurations.
Yeah, thank you. That was from Shabash. So, next we have Fast. Sir.
Let me just set this up. Let me just arrange my windows a bit because everything's just all over the place. Which window went up over there? Okay. Okay, let's see. Revant, you mirrored your screen, is it? You mirrored the screen? Yeah. Okay. Okay, let's try this. It's just because it's not mirrored in my screen. So. You're not supposed to see that. You just swap this out. Okay, so there may be some fiddling on the screen, so apologies on that. I'll just quickly intro myself because every time we plug into display, something or the other happens. Hey everyone, I'm Fuzz. I'm a senior developer advocate at Amazon Web Services, and since today is more of a container-flavored talk, more on Kubernetes, we're going to be covering something interesting in terms of how to get started with Kubernetes, especially if you're a developer like me. Like Revant actually has gone pretty deep into what you could do with Kubernetes. I'll be covering some of the basics at my side, and I'm going to show you, okay, if you're a developer and you don't want to like get into the into the weeds of trying to set up a cluster and like configure the YAML files, is there something better out there? And there is, in fact. And we're going to be seeing some of that. Now, just to keep in mind, there is this. There is this one thing I just wanted to show quickly, because yeah, here you go. See, that's what, even after mirroring the display, it's not coming. Just give me a sec. Sorry about that. Right. Okay, let's end this again. Let's start this once more. Okay, something's really okay. Let's do this. This is going to be awkward, but I'm just going to. So I'm not going to actually show you how to spin up a cluster, because if that's going to happen, we're going to sit here for another 20 minutes twiddling our thumbs, right? So I've already deployed a cluster right now, and I've used a command over here, EKS kettle cluster. Somehow managed to make it work. So thanks, Revant, for that. Thanks for the push. Now, the thing is, we're going to be talking more from an aspect of how to get started with Kubernetes once there's a cluster. See, the thing is, as a developer, when you start using infrastructure, you're more like a user yourself, right? So you have applications, you have code that you're writing. You may need to maybe spin up a cluster at the beginning, but you may not be the one who's actually operating it in production, right? For example, unless you're a one-man team or a one-woman team, which is possible in today's world also. So I just wanted to quickly put that out of the way. So we are not going to be spinning up a cluster because it's already there. What we'll be doing instead is we'll be showing, okay, how you can have some code and then deploy a certain application into the cluster, and we'll see how that works. I mean, with the demos, usually things do work and not. And sorry for the fiddling on the displays. I think for some reason mirroring is not working the way it's supposed to, but we'll see how that goes. All right. So here's the problem statement, and this is where you get started with. How many of you are actually developers over here? People who actually write code, and even if you're not put it in production, right? Okay, so just 3 of you. So the rest of you are all Kubernetes operators already? Okay, okay. Fair enough, then maybe it's a wrong crowd for me. But here's the thing, right? As part of a team, when you're actually building applications and then you're managing infrastructure, you'll notice that you'll have different stakeholders as part of your team, right? So you have developers, you have testers, you have the product managers, and then you have the operators, right, who are actually building the clusters, maintaining the security part of things, ensuring that things are working fine where they're supposed to. So we'll start with the problem statement from a developer's perspective, right? How does a developer actually approach Kubernetes? Because if you're a developer like me, right, I've been 16 years back-end developer doing stuff of my own. In the end, after how much ever infrastructure I want to spin up, this is all I want to see, right? I just want to like have a simple app, say hello world to everyone, get that $1 million in my pocket and then keep on moving. But the fact is that to spin up, even just to have this app, ensure that it is reliable, ensure that it's able to scale well. 1 million people come and say, okay, this is an awesome app. I need to have a lot of infrastructure under the hood to manage all of this, right? So that's kind of like where you want to start looking at how much of this can you abstract. And that was one of the questions on managed services over there, which I think is always a question where you can always answer it as a solution architect way. It depends. A lot of it is about how much control you want to give out, and as a developer or as an operator, how much you want to take control of. Now the focus over here is that you want to abstract away the developer pain, right? So building applications is always hard. I mean, you go back 16 years, and if you're as old as me and one more person over here, because we studied in the same college, you'll know that at that time just having one language and one IDE was all you needed, right? You would fiddle around, make sure that the runtime worked for some time, like a Java runtime. That's how I started in coding. So Java, and then afterwards, once it's done, you are just focusing on your application, and then you deploy it on that one server, and that's it, right? Everything's over. But now it's hard, right? You have so many application frameworks available, so many different ways of writing applications. There's also ways now to not code anymore, right? Low code, no code, and where you don't have to even do anything, something else magically transforms it. If anyone has heard recently about the AI part of things, like GitHub Copilot or AWS Code Whisperer, right? I mean, you have these things that can actually write code. And the only thing I'm waiting for someone to just build an Alexa skill where you can just say to Alexa, hey, Alexa, I want to build a unicorn app to make $1 million. And then Alexa does everything for you. And the point is, throughout the years, you'll start seeing that it's all about abstraction. You're trying to move away from all this undifferentiated heavy lifting, right, of managing infrastructure, of even managing code. Right? You want to write secure code. You need to remember all the security principles. What if there is a service out there, which you can check Code Whisperer, I'm just saying, for actually writing secure code, right? So you want to be more productive, and that's the key thing, right? As a developer or as someone who's involved in building a product, you want to make sure that you're solving the problems at hand for your business. You're trying to deliver business value. It's less about the admin work. It's less about operator work. And in my career, even before I joined AWS, the way I used to look at infrastructure was always, you treat it as cattle. It's never pets, right? So the idea is that as much as possible, automate it and then let it run without you going in every day and then fiddling around with things. So you want to make sure you focus on trying to remove the pain. I understand some people get a kick out of spinning up clusters and managing it. I'm sure there are people who love that because in my time, at least, I mean, now it's Kubernetes. Before this, it used to be Kafka clusters. Before that, it used to be Hadoop clusters. There's something about clusters and people wanting to get their hands dirty, but you want to start abstracting away from it, right? One of the ways we do this in today's world is containers. And for folks who don't know what a container is, it's basically a standard unit of software, right? Where you package up the code, you package up all the dependencies of that code so that it runs quickly and it's able to move from one compute environment to another. How many of you have worked with Java before? 1, 2, 3, 4. How many of you know what was the USP of Java when it was brought out years ago, 20, 25 years ago? Anyone know? Sorry?
Embedded systems run anywhere.
So embedded system is one of the deployment platforms, right? But one of the USPs of Java at that time was build it once, run it anywhere. That wasn't the case actually, but the idea was that you could write the code in one place and then afterwards, based on the compiler, you could compile it to a certain runtime environment, right? And then you could use that runtime environment for like an AIX server, a Unix server of different flavors, Oracle, for example, or you could deploy to Solaris, who a lot of people don't know Solaris is these days what it is. So the container approach is something where you abstract the operating system itself, right? So if you know about virtual machines, you're abstracting the hardware. The idea is that you can have any hardware, it doesn't matter, and then you can run your OS operating system on it. Now you go one level up in abstraction, you abstract the operating system, which basically means you don't need to worry what the operating system is anymore. You just need to know the architecture, and then afterwards you build your code, you write your code, and then package it all with your runtime. So you have like a Java application or a JavaScript application, you have the Node.js V8 engine, for example, or maybe using Python, so you have the runtime inside. You put all the libraries together, you have a container, now you can take this to any container host, right? So containers is something that started coming in, it's been there since the 70s. It's not something that's super new, but then with Docker coming into the realm, and then you have other people now coming in, you have Containerd, for example, another runtime environment. And what these folks do is that they try to ensure that, okay, you have a container, you've packaged it, and you can run it anywhere. And if you see how it evolved over the years, that's kind of like where we come to the whole Kubernetes story. Now, with container evolution, you had applications which were hosted on operating systems, which are hosted on hardware. And then that's basically where virtual machines started coming in. I think that's the one. Okay. Virtual machines started coming in, which abstracted the hardware. And then you had a container runtime that abstracted the operating system, right? So in the end, you have these containers, which now tend to also become big because people start looking at, they don't look at sizes anymore. I've seen gigs and gigs of containers for no reason, but apparently it's needed. And you want to make sure that you're able to then take that container and run it anywhere. And that's kind of like where Kubernetes comes in. So for folks who don't know what Kubernetes is, how many of you have worked with Kubernetes before? I saw a couple of hands. Okay. How many of you have built applications and deployed on Kubernetes? Okay. All right. That's good. So if anyone knows about Docker Swarm before Kubernetes, right? So when Docker came out with the container runtime engine, everyone was happy. They were able to put their containers together and then afterwards run the containers, and everything was good on earth until a year, 2 years later, where people said, okay, I want to run multiple containers and I want to orchestrate all this, right? So the whole idea of, okay, spin up a container, make sure the health life cycle of that application is managed, and then make sure how it can move forward. So orchestration started becoming the norm, right? So Docker Swarm came up over there, and that's kind of like around the same time where Kubernetes started being built out. So Kubernetes initially was an orchestration system, which then evolved into something much more, right? And it was an open source project from Google. There's also a documentary available online. Some of you may have watched it or may have. It's a 2-part documentary. You can have a look at that. It talks about the story of Kubernetes. There's a lot of drama in that. You can definitely watch that. Basically, it's something that's been at the heart of the cloud native movement. This whole idea of cloud native as a concept started being coined at this point of time. And it's not just about cloud being like, okay, you're adopting a public cloud. The whole idea is that the idea is that implementing something like Kubernetes in your infrastructure enables you to have cloud scale kind of capabilities, right? So you're talking about elasticity, you're talking about bringing up compute whenever you want, bringing it down whenever you want, and things like that. Of course, I mean, Kubernetes has its own quirks. It's not free of quirks, but it works for most of the time when you set it up the way it is supposed to, like any cluster for that matter. See where I'm going with clusters right now. So with Kubernetes, the whole idea is that you can run it anywhere on-prem and on the cloud, or even hybrid, right? So now you have services like in AWS, you have EKS Anywhere, which allows you to have a EKS cluster. You have a Kubernetes cluster that could be on-prem, and then you could have one on the cloud and then manage both of them, right? The whole idea with Kubernetes is that it is automatic scaling and self-healing. So you give it all the application, you give it the configuration, and then it manages everything for you, the life cycle and everything else. And the key thing is that it has a declarative resource model. Now, I will come a bit to that, but the key thing to understand with any infrastructure as code concept, right, in the cloud, is that you have some kind of a template engine, for example, for which you provide a JSON file or a YAML file, right? And in that, you declare the final state in which your infrastructure should be in. And once you give it that file, whatever that system is, whether it's like CloudFormation for AWS or YAML file for Kubernetes, it will bring it to that state and ensure that your application, your server and applications all stick to that state as much as possible, right? It doesn't change. So that's basically what you call as declarative. Now, from an architecture perspective, and this is interesting because I used to question this a lot before. I mean, I'm talking about like pre-2000, 2016, pre-2016, where I used to say, with the whole Kubernetes thing taking over the world, literally, I used to say, why are they splitting up this control plane and data plane? Isn't it all, like together, everything's together? And that's kind of like where they started making this distinction. It started, I would say Kubernetes isn't the only one who made that. There were some other systems also who were making this distinction, but now it's super clear, right? So the whole idea is that from an architecture perspective, and you can have a look at the link later, is that you have the control plane that manages how these services run, right? It manages the nodes, it manages the pods, ensures that, okay, the pods are coming in and going out. If anytime there needs to be an update, it'll drain the connections, it'll drain the pods and then bring some new stuff up back again. And then you have the data plane where you have all your actual applications running, right? And these are usually stateless, but then of course Kubernetes is now moving towards more stateful applications. But primarily, even now, I don't know how many of you run a database in production in Kubernetes. Anyone? Okay, nobody's still brave enough. Okay, so the idea is that you would, as much as possible, try to run stateless applications, right? Kubernetes is changing that. I mean, there's a lot of work going on behind the scenes to manage state within Kubernetes. But the idea is that it takes that whole idea of infrastructure is cattle to the next level. Key concepts, I'll just quickly get out of here. So a pod is the basic unit of Kubernetes, and it generally represents a container. Now you can have multiple containers in a pod. It is possible, but it's advisable to have one container per pod, right? And it usually has 4 fields, and that's YAML. So you can start seeing more YAML code coming in right now, and then you can tell me if it's easy to manage this or not. And we can ask the folks who have already been doing it for some time. So you have the API version, you have the kind and the metadata and the spec. You don't create these yourself. As much as possible, you try to like generate this, right? So you have like the containers, you have the image names that you have, and then afterwards you open up the ports that way you need to. Then you have the deployment, and this is kind of like where you're starting to move up a level, right? You're saying that you have a single app or service, and this is basically where you're trying to have multiple parts of the application being deployed, right? So you have the spec .template file, and this is kind of like where you will mention, okay, I'm going to have 3 replicas, I'm going to have nodes, these are all the different containers that I'm going to use, and this is predominantly where you will do a lot of the work in YAML, right? So you have a deployment file in YAML, and that's kind of like where you'll manage all of this. The next level up, you will see that you have something like a service. So this is basically where you have a deployment, and this allows you to have accessibility inside and outside the cluster, right? So you have like IP addresses, you're opening up ports, for example. So you have a node port, you have a load balancer on top. You're kind of like ensuring that accessibility is possible to the cluster, which kind of like brings you to this whole idea of ingress. In this case, you're allowing requests to come in, right? Because by default, when you set up a cluster, I mean, it's basically shut off. You want to make sure that you're able to open up the ports, right? It's something similar to how you start an EC2 instance in AWS. If you don't specify a public IP, it's going to be closed. And the only way you can do that is if you specify an SSH key to access it. So similar concept, you want to make sure that ingress is done. And the idea is that with Kubernetes, you're kind of like managing all that routing. One of the ways I used to convince myself earlier on what Kubernetes is that if you are someone who wants to create your own cloud, basically use Kubernetes, right? You're literally recreating a lot of those components in its own way, right? So a cloud within a cloud, so pretty meta in that case. But that's kind of like how you want to see Kubernetes, right? And again, like the folks over here who are already practicing it, they can tell you more stories, good stories and horror stories. I'll let them decide. Right, so this is well and good, and with Kubernetes you see that there's a lot of YAML files that you use, and then you're setting that up, and then afterwards making sure that the YAML files are able to bring your cluster to a certain state. Now in general with AWS, there are certain ways you can do that for resources that you spin up in AWS, right? Infrastructure as code as a concept is something where in AWS you create a YAML file or a JSON file for your resources, a declarative file, and then you present it to CloudFormation, which is a service. It takes that YAML file, and then afterwards it then creates those resources, provisions them, and then keeps them at the final state. So to give you an example to folks who have not seen an AWS page before, perhaps, let's see if I do this right. Okay. And I kind of realized that, in fact, it's almost like this talk has become a mix of IAC plus CDK plus Kubernetes and everything. I mean, so if, for example, if I give a template file for something like, let's say, okay, I did the serverless workshop, so I'll just show this quickly. And these are not Kubernetes, but you'll get an idea. Is that I have a YAML file where I'm providing the resources, and I'm saying these are all the different services that needs to be created, right? And then what it will do is it will just create these services, provision them, and if something goes wrong, it will roll back automatically based on the service, right? This is what I was trying before. I was trying to set up an EKS Fargate stack, and what actually happened was I called it too many times. I mean, basically internally it was creating the stack too many. It was accessing the APIs too many times, and then I hit a rate limit. Well, let me see if I can find that. There you go. Right. Yeah, so it's too many requests. So that's basically why I tried to ensure that I have a EKS cluster beforehand, because I didn't want to show you folks and then get that error in the end. But that's kind of like how infrastructure as code is, right? So if I then move back to, this, okay. My slide went. Right. So now with infrastructure as code and with YAML, Kubernetes YAML, and folks who have written a lot of YAML file will know YAML is great in a certain way because you're declarative, you can make things proper, you can lint it, you can do version control. But then when it starts coming to managing the multiple YAML files, it becomes a pain. So I have done a lot of CloudFormation before CDK even came into norm, and I know the pain, but then I got used to it, so I can still do YAML, which is fine. But the idea is that you need a certain abstraction. So like containers as an abstraction for your application code, which abstracts the operating system, is there a way to abstract your infrastructure, right? The infrastructure as code part of things. And that's kind of like where AWS released CDK, Cloud Development Kit. And the idea is that you have this multi-language framework which allows you to write code and under the hood generate that template file for the actual infrastructure, right? So the idea is that you use a language that you're familiar with. So if you're a developer, for example, like a Python developer or a Java developer, and then we support these languages right now, so C#, Golang. If there's a language that does not exist, just let me know and talk to me, and then we can see if there's something coming up soon or not. But the key thing is that you get tool support because you can use your existing ID, right? You can do a lot of your, you can use your linting code and anything else because it's just like any other code. You import libraries and packages. You can add constructs of your own also within the code. And in a nutshell, this is what it looks like. So if you, for example, in the cloud, you're trying to create a VPC, which is a virtual private cloud, which basically is an isolated network. This 1, 2, 3, 4 lines of code basically is going to create all of that YAML file, which will create all the VPC and everything else. Why? Because in CDK, you also have certain opinionated stacks that are available, right? So when you create say you want to create a VPC, it'll create all of this. But if you have a certain opinionated way of creating a resource, you can also create a construct of your own. So think of it as a library that you create of your own, and then you import and then provision all those resources. So that's kind of like what CDK brings to the table. And we have a lot of examples out there, and I can share the links later on what you can have a look at CDK, especially if you're using AWS. Now, the key thing is CDK works only with AWS cloud, right? So the whole idea is that because it's only for CloudFormation templates. The flow is simple. Now, so you install the CDK CLI, and once you have the CLI ready, you create a project. And in this case, once you create a project, you can then okay, before publishing, of course, you write the code. So you have the stack and then you have constructs, right? So to give you an example, I already have an application that I have created over here. Once I can access it, let me see if I can access it over here. Okay, yeah, so everything's over on this window, strangely. Okay, let me just get this out. So if you do CDK init and then you provide it like, let's say a sample template, you can say Python or whatever else, it will generate an auto template, for example, which uses SQS and SNS and all that other stuff. But then what you can do is then you can change all of that. So for example, in this case, what I'm trying to do is I'm trying to create an EKS cluster, okay? And as part of this cluster, what I'm doing is I'm creating a VPC in this case. And then I'm also telling it to create a role. So anything that you do within AWS, within the account, I'm actually mentioning that as part of my code. And then I'm creating a cluster where I'm mentioning, okay, here's the construct ID, something clustered, so name it for the ID, give it a name, assign it the VPC that I created earlier, assign it the IAM role that I created earlier, which is just like any normal language, right? It's just giving assignments. And then you can then create a default capacity instance, EC2 instance type, and blah, which is similar to the command that I just showed in the beginning, right? I created an EKS cluster using EKS kittle, whichever way works for you. I'll leave it to you to decide. And then also mention what's the version in terms of EKS. What this does is then it will create a CDK, it will create a file. I didn't do a synth on this one, but it'll create a template file which can then be used to deploy, right? So I won't go too much into CDK in this case because I want to go back to, right. So let me just do this. Okay, cool. So that's with CDK, right? And that worked. Now, what happened was when Kubernetes as a concept started growing more, we started seeing with developers in general, everyone saying, okay, fine, we are doing a lot of YAML development again, right? Like CloudFormation. And CDK was built so that it can abstract that pain away. So the team at AWS thought, okay, is there a way for us to leverage CDK to ensure that we can actually, make it easier to develop Kubernetes clusters, right? And all the configuration files. So the whole idea was to take CDK and then repurpose it, or more like have that as a base and then build this out where you have this multi-language software development framework again, which models Kubernetes resources as reusable components. So again, it's the same thing. You use CDK 8S and then afterwards you write your code for your Kubernetes cluster and you have all those configurations as code now. And then you do again synthesize and then create a YAML file, which you can then deploy directly into EKS So in this case, you can also have best practices, which is great because a lot of times, a lot of customers we see what they do with Kubernetes is that they'll have a lot of YAML files which are standardized and they're kept. But then if you want to adapt that, and you have to go in and then start changing the files yourself and trying to repurpose that. But when you have it in code, you can actually run it as a library, as a package, and then run it anywhere. Now here's the thing: unlike CDK, which runs with the AWS cloud, CDK ATOS can run anywhere. So you can run this locally on your machine. Right, it's going to generate a standard YAML file for Kubernetes, which you can then deploy to any Kubernetes cluster. So that could be on AWS, it could be on your machine, it could be on-prem, or on any other cloud if you need to. Right. So the YAML file is cloud agnostic or provider agnostic, at least from that sense. And if you see what happens, for example, we are taking, I didn't go in depth into the different parts in Kubernetes, like the Helm charts and all that. Just a brief is that a Helm chart is kind of like if you use Node.js NPM packages, it's a package manager for Kubernetes, and it's become a very powerful package manager, to be honest. I still remember when there were growing pains initially, but now it's become much easier. In CDK ATOS, it takes the same concept because you create a chart, right? And then you can then create a deployment within that and then describe your application, provide the resources, and then under the hood, it will generate this YAML file behind the scenes, right? Then you can just take this and then apply it. So the workflow is a bit similar. So you have CDK ATOS, you create a project, and then you have charts, and then you have constructs, which you can then reuse. And this source code is something that you can then use, and then you can create manifests out of it, and you can also publish it. So one of the ways we see this being used a lot is especially in a GitOps approach, where you are using your infrastructure code like your normal code and then having Git flow around it, right? The whole idea of your infrastructure being deployed as part of your push to the repo. So you can use GitOps flows. So you have Weaveworks who has, like, they brought up the whole GitOps model. You can use Flux as part of that if you need to, but predominantly you can just deploy this in any CI/CD pipeline, and that would then deploy the applications to your Kubernetes cluster like any other normal cluster, right? Because before this you would just have to create the YAML file and then upload it, commit it to your repo, and then have something else take it from there and then deploy it. So that's kind of like how you want to see the workflow in this case. I'll quickly show what CDK ATOS does. In this case, I'll just find out where my terminal is. I think it was here somewhere. Wait, let me see. Okay. Just a sec. There you go. Yeah, I'll just find where that the code is. Oh, there you go. Let me know if this works. Okay, cool. So in this, so I just created a simple app, right? What this does is this creates a service where you have a load balancer, and then afterwards I have a deployment as part of the setup within Kubernetes where I'll have replicas of the app set up, right? It's a straightforward Hello World app. It doesn't do anything much, and there's a Hello Kubernetes the name, and I'm using an image which is basically Hello Kubernetes 1.7. So anyone who's done Python before, this is something that they can follow straight away. You can also do this in Java, Go, or TypeScript, and .NET. .NET is not there. No, sorry, .NET is still not there. Yeah. So Golang is available. Yeah. So in this case, I have this ready. Now what I do is I just have CDK synth run, and once I get my cursor over here. So all I'm doing is I'm telling CDK ATOS to take my code and then synthesize the YAML file, right? And then I have this hello KATOS YAML file, and all I do is I just do a cat and it gives me a standard YAML file, which I can then take and then deploy directly with my EKS cluster or any Kubernetes cluster for that matter, right? So in this case, I have a port that's running, and then afterwards I have the load balancer. I create a deployment of type. Hello deployment is there as a name. I have the replicas and also the container image which is available. Pretty straightforward, and it works in a certain way. What we have seen some customers do is that they use they as much as possible try to automate the deployments to Kubernetes using something like this. And because it works even without the cloud, right? You can actually deploy this. You have a lot of developers when they have a development workflow with a local Kubernetes cluster, they will write the code and then keep this ready, generate that, run it on that local Kubernetes cluster, test everything out, and if it works fine, then push it, right? So commit the code and then push it across. So that's kind of like how you want to see CDK is actually working. And then when you deploy this, it just deploys the way it works. In this case for the Kubernetes cluster. Now, if I can find where my presentation is, let me see. There you go. Okay, so I'll just quickly mention about EKS in this case. EKS is a fully managed Kubernetes service, right? So the whole idea is that if you have your own Kubernetes workflow already running from a developer perspective, maybe you're running Kubernetes in on-prem somewhere, you can actually deploy Kubernetes and a managed Kubernetes service in AWS. So you have a couple of options. You have one where you have the control plane and the data plane within your account directly, and then you have something like Fargate where it's where the control plane is managed, right? And the idea is that as much as possible, you want to remove the undifferentiated heavy lifting of managing a Kubernetes cluster, right? Depending on how much you want to take it. So we have customers who are okay with giving that control with AWS. They just provide the image and then provide some configurations and the YAML files for Kubernetes, and then everything else is managed. Versus some teams where they say that they would want to tweak everything. And as much as possible, what we do is we keep it as close as possible to vanilla Kubernetes, which is we are always, I think, a version behind whatever's there in master. That's kind of like how we at least mention it. So production workloads is something that you can use. We have a lot of customers who's already using that. How many of you know that we have launched a UA region? Okay, good. So half the crowd knows already. EKS is still not available, but it's coming soon. But we have ECS, so you can still use ECS, and I could have given this as an ECS talk, but no. And that's something, and we have seen that that's one of the biggest requests, right? Because we see a lot of Kubernetes deployments happening in the region, and not only UAE, we're talking about like the whole of MENA. And I think a lot of that is because definitely with customers who are looking at sovereignty as an idea for data, right? Data sovereignty, to keep data within the country, they preferred going with cloud technologies by actually creating their own stuff within on-prem and then waiting for data centers to come out. So now the UA region is available. EKS is going to come soon. That's kind of like where you would want to start looking at, okay, how can I start moving my clusters and managing that on AWS, along with all the other awesome services that we have and is being launched. One of the things I had done was I had created a serverless demo app using the UA region, and that worked because I was able to do like API gateway, Node.js on Lambda, and DynamoDB also worked. So I was able to do that. I put that on LinkedIn, simple demo. Just mention Marhaba become for AWS, and like some people were happy with that. So that's kind of like how you want to see that. No, so that's a managed service that we have right now, and we have like customers, like I mentioned, who are adopting this around the globe in this case. So that's kind of like where you want to see whether Kubernetes as a concept, if you already are deploying that, because there are some folks who are already using that, which is great. You want to see how you want to use tooling like this. There is so CDK8S is already there is a website that has a pretty awesome documentation. Once I can find my Chrome tab. Okay. So you have a cloud development kit for Kubernetes, and then you have a getting started page over here. In this case, you can just get started directly. It's also, wait, let me just go back to that. So it is also part of the Sandbox project. So it's something that's going to be in incubation. It'll take some time for it to come out. Once it comes, you'll start seeing it in the landscape in CNCF also. And there is some traction. We are seeing a lot of contributions coming in. So people who are interested in OSS contributions, feel free to provide your inputs and your PRs to this. And this is kind of like where you can look at how you can create your charts. We also talk about migration. And in this case,
You can create constructs for Kubernetes API. So something that you can use, especially when you're having a distributed team, you're having multiple people actually creating constructs and then reusing that as much as possible. So that is one. The second thing is we have CDK in general. And you can use this to get started. So there's a button itself, get started with AWS CDK, which is awesome. And you can use this. You can install the CDK library in this case, or you can install the CDK CLI also, and then start creating your resources directly with any of the languages that is available over here. And we see customers using this. We see a lot of conversation between whether to use CDK or Terraform or Pulumi, for example. And what we are seeing is slowly there is more adoption for CDK, especially from the folks where they're trying to reduce the burden on the operations team as much as possible. We have certain customers where they say, where they ask the developers to create templates for resources on AWS, right? And for developers to do that, then they would need to either learn CloudFormation, or they could just do it in CDK, which makes more sense. And then they provide that CDK code, synthesize the template, and then give it to the ops team. And then the ops team then validates that, they do linting on top of that, and then they run it again. So CDK is something you can definitely look at, but of course you don't have to use CDK to use AWS. It's just another abstraction that allows you to free up the amount of time that you want to spend actually in something else better. So that's kind of like how you want to look at CDK and CDK ATS. And that's it for my talk and demo. Any questions? Revant.
Which one would you prefer, Terraform or using this one for provisioning your infrastructure?
Repeat the question for the.
Oh, okay. So the question is, what would I prefer? In general, what would one want to prefer, whether it's Terraform or CDK? Now, here's the thing. We are partners with HashiCorp, right? So we have a lot of workshops also that we do with Terraform. CDK also supports Terraform now. As part of there's an integration that's available that allows you to, I believe it is creating Terraform templates. Let me just confirm that. CDK for Terraform, right? It creates the templates, if I remember correctly. Let me just check CDK. There you go. Right, so you can generate Terraform from CDK directly also. So this was just announced actually pretty recently. And what this does is this creates your Terraform files. Now, what we have noticed is that okay, so there is a distinction you need to make. Some folks, they come in with this idea that if I adopt Terraform, I can do any cloud with Terraform. Now, yes, you can use Terraform as such to manage multiple clouds, but the constructs that you use inside is going to be different for most of them, right? And even the folks that created Terraform, they have a podcast, they talk about this, they talk about the distinction. So you would want to look at Terraform as a way to say, okay, fine, if my team wants to invest some time in one infrastructure language, spec for example, what's the best way I could do it? Okay, let's do Terraform, because anyway everyone needs to learn HCL as part of this. That being said, there are some advantages of having a managed service within a cloud provider to manage your infrastructure. So CloudFormation, for example, manages the state for all your resources that you provision. In Terraform, you need to ensure that that state is kept somewhere. And if you lose the state, then you're basically, like you have to start from scratch again. Which is why then Terraform also has a cloud offering where you can manage the state in this one, or you could store it in S3 buckets or in even DynamoDB for that matter, depending on how you set it up. Or GitHub, right. So that's kind of like how you want to see it. Personally, I would, as a developer, I would prefer to just write code than to actually write templates. So even with Terraform, I see with the templates and all, you can definitely understand it, but it's one more language you need to learn. Right? So HCL is different from YAML, totally. Right? It is definitely more, it's more, I mean, it's something you look at HCL, you can actually understand a lot of it, but then the more complex it goes, then you kind of like starting to get into YAML territory again. So that's kind of like how you want to look at it. It would, as a team, if you want to choose, then yes, you would want to take the skill sets and then of course, the engineering effort on whether everyone wants to invest on this and the tooling around it as part of that.
YAML is a language or it's framework?
YAML is a language. So YAML is basically yet another markup language because whoever thought of that said, okay, let's create just another markup language, and the way it looks something like this. Where's my oh, okay, sorry. This is basically YAML. So it's space sensitive, right? And you have indentations as part of this. You have keys and then you have values. right? So you don't have like in JSON, you don't have braces. You don't have objects per se, but this kind of like relates to an object. So in CloudFormation, you can have a JSON file and then you can have a equivalent YAML file, which looks almost similar. So that's kind of like how you would use it. YAML is less verbose than JSON, but it's still verbose. And of course, the indentation is always a pain, especially if you have massive YAML files. You can ask me how I felt that, but yeah. So yeah, that's on YAML. Terraform. Okay, so that was one. Next.
The output of a CDK project is a YAML file.
The output of a so when you do CDK synth, so when you synthesize a CDK project, then you will get a CloudFormation template, which is YAML.
So we still depend on the kubectl.
Sorry?
We still depend on the kubectl.
Yeah, you do. So with CDK ATOS, yeah, so with CDK ATOS, all you're doing is you're abstracting, writing the YAML file for Kubernetes, right?
The applying of the YAML files still has
You still have to do kubectl. Yeah, so you can use kubectl. I don't know if the roadmap for CDK ATOS has this option where they're going to like do a direct deploy. That's something I'll need to check. But it's an open roadmap, so you can definitely have a look. And maybe some people have raised that, right? They're saying like, okay, why don't we? You're doing all of this, just do a CDK deploy. Like CDK deploy has an option. You could do CDK ATOS deploy and then do that. Maybe it's already available. That's something you can definitely check out. But yeah, it's. I would definitely prefer that, to be honest. One less thing to worry about. But that being said, we have couple of kittle CLIs, right? So you have kubectl, you have EKS kittle for EKS, and yeah. So I don't know. I mean, which one they're going to stick to? Maybe kubectl. I don't know. So yeah, cool. Any questions? Yeah.
Yeah, actually for complex Kubernetes deployments, I usually use Helm. So
Yes.
how is CDK more better than Helm?
Yeah, so so for complex deployments on Kubernetes, the gentleman uses Helm. So how is CDK actually helping to address that? I mean, how is it better than Helm? So one thing I had mentioned earlier was in CDK ATOS. Once I get this thing over here. So if you notice over here, you're actually creating charts. I mean, so you can actually define a chart within CDK ATOS as a way to start creating the YAML files. So you can create your Helm charts as part of this, right? As part of this, as part of CDK ATOS, and then when you synthesize it, you can then reproduce it. In the end, you're still going to use Helm charts under the hood, but the idea is that you're not actually going to write them in this case. That's kind of like how you want to look at it. You would still use Helm, right? Because you still need a package manager for Kubernetes.
What is the advantage of it? If I still need to use Helm.
Writing YAML versus Python or JavaScript, I think.
Yeah.
In one line, that's the answer.
So it's like what's the difference between just writing code in CDK in general and then writing the YAML file for the infrastructure? Because anyway you can write the YAML file, which is what CDK will generate. It's the same thing for CDK ATOS. So what you're doing is you're defining what your chart will look like in Python or in Java, and then when you synthesize it, it's going to create the YAML file anyway. But you're not creating the YAML file yourself.
But in Helm also, we are not creating it ourselves.
That's recently, right?
Yeah.
Yeah, that's recently.
Huge library available.
Yeah. So before this, in Helm, when you had to create your Helm charts, you actually needed to hand code a lot of your charts initially. I'm talking about like 3-4 years ago. A lot of that has changed. They've done a lot of, I think version 3 or version 4. I forgot which version it is right now because it's just moving. So in this case, what's happened is Helm has actually taken that, and I think as part of your when you include the libraries, then under the hood it will use all those Helm charts under the hood, right? As part of that. So you're kind of like chaining all of that together and then creating it. In that case, I would say have a look at what CDK ATOS can do if there is a way to address some complexity in that, or else it's more of, okay, if I'm just going to create normal Helm charts and then manage it myself, you could use something like this. But if the Helm CLI, you're able to just manage everything through that, then great. So think of this just as an abstraction layer on top where someone like me as a developer doesn't need to manage YAML files directly. I could still generate it. Huh?
So one more use case is like this is code. You can put if check, if this is dev, do that. If this is prod, do that. Theoretically, you can write logic here, right? And it will work. In YAML, you can consider, right, how complex that would be if you want to do that. First, if whatever you want to do, can you do that in YAML? Or second thing, if you just pass certain parameters and based on those parameters, your whole code behaves differently. So that you can't do that in YAML. So that's where this whole idea is there that everything is code. Everything can have logic. Everything can have parameters, and can modify itself based on certain external parameters.
Right.
In YAML, you cannot
Right.
have one YAML for every environment which have certain type of if checks and loops and so on and so forth. So I think that's the idea rather than
Because it's like any programming language. You're writing code, you can have constructs inside, you can have logic and a lot of other things. But that being said, if you're already comfortable with the Helm, there's nothing wrong with continuing with it.
I feel like it's just a matter of choice. Because
It is a choice. It is a choice.
What use case, what he has said regarding the environments also, that is also available in Helm also.
You could put that as part of the
Which you deploy according to the environment.
right, because in Terraform and HCL you can do conditions.
Yes.
So Helm would have taken something similar. I mean, a lot of these are borrowing from each other. So with CDK also we see the same thing. So if you ask me personally, I would use CDK a lot for a lot of clusters which I'm generating for the first time. But then if I'm managing some of the templates myself, I have the CloudFormation template. It's just easy for me to do Control F and then go in and just change it, right? So you're right, it's a choice. So whatever I'm showing right now is a choice. It's more like, okay, for folks who just want to get started, right? For someone who doesn't want to, like someone like me, right? I see a lot of development happening in Kubernetes. There's a lot of stuff happening, right? And I just want to take it step by step. I want to make sure I'm able to deploy something to production now, abstract some of that, and then slowly dive deeper into certain things. So that's the way you do it. It's a choice. That's how it is.
So, are you saying it is actually using hand charts under the hood, or is it something which is directly converting this code to YAML of Kubernetes?
This is converting to YAML of Kubernetes.
And it has nothing to do with hand charts.
It does create it. Let me just
Because,
confirm
like,
that one.
Why would you use the word chart then?
Let me just confirm that for you again once more, since we're talking more about Helm charts.
If Helm updates their version, then this would fall away.
It's a valid question. Let me just see. There you go. So you have an object that you can reference as a Helm object. Yeah. So you have a Helm deployment that you can do as part of this construct.
So I can still use Helm and then use some of this to.
You could mix and match. You could. Yes. At the same time, you can also, so in the end, if you're creating a final YAML file, you're definitely going to just use that directly in your Kubernetes cluster, right? So that's kind of like how you want to see the abstraction in this case. And I'm guessing what may happen is over the years, with a lot of the development that's happening in this, it's going to start taking in more of the libraries and frameworks that are there right now on Kubernetes, adopt that, and then afterwards make it easier for developers to at least use this, right? For folks who are already used to YAML files, whether it's in Helm or in general, it's just a matter of, okay, do I need to write code or not?
you can use CloudFormation also.
You can use CloudFormation, exactly, yeah. I mean, it's a joke, but I still remember I gave a talk in a DevOps talk in Malaysia, actually. And one of the questions somebody had asked us, if I write bash scripts, am I a programmer? I said yes. Another guy said no. And he's someone who's a sysadmin and a developer. So I'm like, all right, fine. I mean, whatever works. I would say if anyone can write an if condition in the code that you're writing, you're a developer already, right? And that's the end of the discussion over there.
Then moving forward, everybody would be a developer.
Yeah.
I mean, you're kind of like broadening the whole idea of what a developer is, right? With the cloud especially.
Infrastructure is code.
Exactly. In fact, there's a new term that's come out. So there's now new roles that are coming out called automation engineers.
Yeah.
Yeah, and automation engineers are basically folks who are writing infrastructure code, right? So they are engineers, software engineer, developer, yeah, same. Automation engineer, automation developer, yeah, same. I mean, you could say, okay, a person who's not writing code, but he uses a low-code tool for generating, and there are some tools available. I'm not sure how many of you are familiar with some tools that are out there, which are currently on LinkedIn. My feed is filled with a lot of tools that do low code. You drag and drop infrastructure, connect them together, it will generate Terraform code for you, right? There's one of them called Brainboard, brainboard.co.
So you just
Exactly.
click that.
Yeah. So the question then would be, are you a developer or not? But that's a discussion for pizza, not live on YouTube. So sorry, folks, whoever's on YouTube, we are not going to do the discussion live. But yeah, that's kind of like how it is. So yes, with Helm, it's there. You can use it and then you can reference the properties. Any other questions?
Let's call it.
Okay, cool. Let's call it a day. I think we've got our pizzas. Oh, awesome. Thank you. And thanks, folks, on the YouTube channel. We are going to go for pizza, so I hope everyone have a great evening ahead. If you're missing the pizzas, make sure you come for the next meetup. Yeah. And with that, see you all and have a good night.